Greetings and welcome to the first video on graphing in the coordinate plane. This one is just an introduction to the coordinate plane and kind of sets the groundwork for things like finding length between 2 points and then also plotting equations using tables and analyzing those relationships. So as we get into it, just know that graphing is, let me get something to write with here. Here we go, Apple Pencil. So graphing in the coordinate plane, it's a visual representation of the relationship between two quantities. And so those are usually labeled on one of the axes, and we will get more into that in a moment. So when we are graphing, we are going to be using coordinate pairs, and that's just a particular point on a plane represented by an x value, which is the horizontal distance from the origin on the x-axis, and a y value, which is the vertical distance from the origin on the y-axis. And those, very, very, very important, are always written in that order. Has to be that way, no exceptions. So ordered pair is just a synonym for our coordinate pair. X-axis is the horizontal axis, y is the vertical. We'll look at a picture of this in a moment. And then a quadrant is a way to describe the general location of a point. They're numbered counterclockwise, and they're always written using Roman numerals. And then perimeter is the sum of the lengths of all sides of a polygon. We'll be focusing mostly on rectangles, and we can use that formula. So looking here at this picture, we have, first off, going horizontally this way, we would label this as our x-axis, and vertically is our y-axis. And then, as you can see, those both intersect at this point here in the center called the origin. And I guess I probably should have added that to our list of vocabulary. But origin is the point 0, 0, where the two axes intersect. And before we get into the quadrants, I do want to point out that it's essentially you have two number lines that start at 0, and then as you go right, if you're horizontally, the numbers increase, and they are positive. And then left, they decrease, and you're dealing with negative numbers. And then the vertical, the y-axis, is just the same thing essentially, except it runs vertically. So as you go up, things increase, and they're positive, and then as you go down, they decrease, and they're negative. So it is pretty similar to what we looked at in chapter 2, I believe it was. So if you need a refresh on that, go check out those videos. Now, when we look at the quadrants, we would say this is quadrant 1, starting right here. And it's in quadrant 1, your coordinates are both positive. So your x value that you go across this way is positive, and then your point is going to be positive as well. So the coordinates for A in this situation, our x value, if we look down, is a 2, and our y value, if we look across, is a 3. And so that point A is 2, 3, and it's always written in parentheses with a comma. And then if we were to look at point B, that one is going to be in quadrant 2. So notice we're going counterclockwise. So we started in quadrant 1, and we're working our way in the opposite direction that a clock turns. And in this quadrant, the coordinates, our x values are negative, and the y values are positive. So if we look at point B, you notice if we start at the origin, we have to go to the left, so that's negative 2 units. And our y value is still above 0, so it's going to be 3 units up. And that's how we would find point B. Quadrant 3, as we continue around, our coordinates are going to both be negative. So our x values are negative, and our y values are negative. So if we look at point C, again, starting at the origin, we are going to go back or into the negative 2 units, and then we are going to go down 3 units. So they are both negative. And last but not least, let me grab blue, I suppose. Quadrant 4. In this quadrant, our x values are positive and our y values are negative. And so if we're looking at this one, that means point D has coordinates of 3, sorry, 2 units, because starting at the origin here, we went over 2 horizontally, and then we are going to go down 3. And so what's nice about identifying these patterns for each quadrant, that quadrant 1 is both positive coordinates, quadrant 2 is negative positive, quadrant 3 is negative negative, and quadrant 4 is positive negative, just by looking at a point, the coordinates for a point, the ordered pair, you can identify which quadrant it's going to be in. And that can help you when you're graphing so you don't accidentally make a mistake. So, looking at some sample problems, and I pulled these from the review, but I think they are a nice practice at this. So if we're looking at point A, which is right here, we know that it is in quadrant 3, so I'm just going to write that down, quadrant 3, because this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, and from what we looked at up above, I know that my x value, because I have to travel to the left of the origin, my value is going to be negative 4 units, and we are traveling below or down from the origin, down from the y-axis, the x-axis rather, and so our coordinate is negative 3. So the ordered pair for A is negative 4, negative 3. And notice that yes, you absolutely must have the parentheses, you must have the comma, and when you write the quadrant number, it is always in Roman numeral form. So B, if you notice, B is, if we start at the origin, we go nowhere. And so that means that point B is at 0 for our x value because it's right on the axis. And then we travel down 6 units, so negative 6. And we would say that this one isn't on any quadrant. We would say that this is on the y-axis between quadrants. Let's see, if we're right here, it looks like that is between quadrant 3 and quadrant 4. So notice these points that are on the x-axis or the y-axis, they're between 2 quadrants. They don't live in any of the quadrants exactly. So point C, I know we start at the origin and we go over 2 units to the right, so that's a positive coordinate, and then we're going down 4 units, which is negative 4. So you could count them 1, 2, 3, 4. And that is quadrant 4. So I'm going to stop there because I think you get the point on this. D is 6, 3, and that's quadrant 1, and then E, fine, I'll finish them up, why not, is negative 2, 3, and that's in quadrant 2. So that's when we are looking at a coordinate plane and then pulling the coordinates in the quadrants. If we look at this one here, now we're given the points, so we're given the ordered pair, and we need to place them in the appropriate quadrant. So for this one, I'm going to look and see. For point A, both coordinates are positive, so that I know that's going to be quadrant 1. Now when I go to plot it, because 3 is positive, I'm going to start at the origin and travel on, and our coordinates go x and y, so that means I have to go on the x-axis to 3, and then I need to go up 5 units, 2, 3, 4, 5. So that is where you put point A. Point B is negative, and it's, 0, and so this one's not going to be right. Not going to be in any particular quadrant, because it's going to be on the axis. So I'm going to plot that point B, and it's negative 2, so starting at the origin, I'm going to have to go left this time, 2, and because my y value is 0, I have no vertical distance traveled. So point B is on the x-axis, and that's between quadrants 2 and 3. So again, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Point C has an x value of 7, positive 7, so I'm going to start at the origin, go over 7 to the right, and then down 2 because our y value is negative. So point C is right there, and that means it's in quadrant 4. And that does fit with what we observed above. We have a positive x-coordinate and a negative y-coordinate. Point D, our x value is 0, so we don't travel anywhere from the origin, but then our y value is negative 5, so we have to go down 5 units. So D is at 0, -5, and that's going to be on the y-axis between 3 and 4. Awesome. And then point E is going to be -3, so our x value is to the left of the origin to -3, and then down 8. So right here is where point E is, and that's right on the edge of quadrant 3. So that's plotting points and identifying the quadrants, and now we move into finding the length of a line segment. So the first thing this asks us to do is plot point A at 1, -1, so I'm going to go to the right on the x-axis 1 unit, and then down on the y, down from there 1. And so that is point A. And then point B has an x value of 7 and a y value of -1. So that means I go to the right 7 units and then down 1. So point B is right there. And then we make a line segment. So to show that it's a line segment, we would write it like this, and you put that line across the top there. And now we need to find the length of that. So we have two options. When you're finding the length, you can, option A, I guess we'll call it, is you can just count. You can count the number of intervals, the number of spaces. So starting at A, we have 1, 2, 3, 4, 5, 6. So the length of that line is 6 units. Now there are times, especially in the future, where you're going to need to know how to do some calculations because the points aren't going to be quite as friendly as that. And so we've looked at how you can use absolute value. And so when you're using absolute value, if it's a horizontal line, I'm going to make notes of these down here. When you're finding the length and it's horizontal, you're going to use the x coordinates. And if it's vertical, you're going to use the y coordinate. Because if we look here, the length of this is really, what is the difference between 1 and 7? And so, because these could be negative or they could be positive, what we want to look at is how using the absolute value. So we would do absolute value of 7 minus the absolute value of 1. And the reason why we're using the absolute value is because we want to know the distance from 0. So absolute value is the distance from 0, and this tells us where that point is and then how long that line is going to be. Now this one's kind of boring because they're both positive numbers, but we'll look at another example where they're negative and how that's going to change what we do. So absolute value of 7 is 7 minus absolute value of 1 is 1. So that is 6 units. So when we use that absolute value, we were able to calculate the same thing. Now, if we were to say have a point C and then I'll put point D right here, point D, and we want to know what is the length of point C and point D, we're going to have to do something a little bit different. And we will continue using the absolute value, but this time we're going to break it up because we want to see basically how far is point C from the origin, and then how far is point D from, how far is point C from the x-axis, and then how far is point D from the x-axis. And then we're going to want to add those. So we would write this and say the absolute value, and notice this is vertical, so we're going to use the y coordinate, and C is at -5, and D is at -5, -6. So we will take the absolute value of 5, because that's our y coordinate, and we're going to, instead of subtracting this time, we're going to add that to the absolute value of -6. And absolute value of 5 is 5. Bear with me. Plus the absolute value of -6 is 6. So those 2 points are 11 units apart. Oh my gosh. Guess what? That's at 4. This whole time, I tell you. Let me change that. Apologies. So that means this, and all of that is wrong. Because this is going to be 4, 4, and that's 10. Okay, sorry about that. So the reason why we want to add this time is because, like I said earlier, we looked to see how far is point C above the y or the x-axis. And if we count those units, 1, 2, 3, 4, this is 4 units away. And then point D is 1, 2, 3, 4, 5, 6 units away from that x-axis. So because those points go across the axis, we want to add them together, because that total distance is going to be this portion here, those 4 units, plus these 6 units, and that would get you overall 10 units apart. Now, we could just count those as well. Yes, 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 you could. So the way we remember this is that if you go across an axis, add, so you can see across an axis, you need to add. If you're in the same quadrant, you subtract. So you can know that across, add, same, subtract. If we look at A to B, we subtracted right here. And then C to D, because they went across, we needed to add them. Now, let's see. If we look here, this diagram shows a plan of a room. Side length of each square is 10 feet. So on our coordinate planes, the distance between the squares can vary. We call this our scale. And so in this problem, 1 square is 10 meters. Feet, 10 feet. Where in our other example, if I scroll up a little bit, each square here is just 1 unit. And so you have to be careful. And that's where counting is okay when you're calculating lengths. But if you use the coordinates, the ordered pairs, to figure it out using absolute value, you don't have to worry about counting and then multiplying or whatnot. But we will look at a couple of those examples here. So this question wants us to figure out, first get the coordinates for each point. So A is at -40, 100. B is at -40, 20. C is at -60, 20. D is at -60, -40. E is at 60, -40. Oh my gosh, that's a terrible 4. All right, F is at 60, 20. G is at 40, 20. And then H is at 40, 100. Okay. So now, I think one of the questions is about the perimeter here, kind of here in Jenna's land. And so I'm going to talk about that first, where if we wanted to figure out the length of AH, we could count the units. So let's do that. We know that there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 squares, but each unit is 10 feet. So we would need to multiply 8 times 10, so that side AH is 80 feet long, has a length of 80 feet. Now if we wanted to use the absolute value, it's a horizontal line, so we're going to be using the x value because the x-axis is horizontal. And we are going across an axis, so we need to add. So we are going to do the absolute value of -40 plus the absolute value of 40, which is 40 plus 40, or 80. And we got the same answer, 80 feet. And so those are the two ways. What's nice using the coordinates is that you don't have to worry about converting the number of squares by how big each grid is, but it does get you that answer there. So looking at this entrance of the room being situated alongside A through A to H, AH is this side here. What is the shortest possible distance between the entrance and the side of DE? So DE is down on this end. And so we know that there's going to be a door put in somewhere in this green area. And so we need to know how far is it from the green all the way down to the red? So we could use any of these points. It's going to be basically like a line was connected from A to, if we put another point here, let's call that one point J. We want to know how long is AJ, and J is negative 40, negative 40. So this is a vertical line, so we're going to be using our y coordinates. I'm going to start out and use the absolute value. So it would be the absolute value we're going across, so we're going to be adding, of 100 plus the absolute value of negative 40. 100 plus 40 is 140 feet. So if we wanted to count, we could check and see and do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 grids, and each one is 10 feet. So that must mean it is 140 feet. So we got the same answer. We know that no matter where that door is placed along this green side, it is going to be at least 140 feet, vertical feet away from here, vertical on this coordinate plane. All right, and we're going to ignore this Jenna question because that is about the perimeter. So just be calculating a lot of side lengths and then doing some addition. A couple of things that I just want to reinforce one more time is that x-axis is always horizontal, y-axis is always vertical. Coordinates are always, always, always written in this form. And please make sure that when you do your quadrants that you write them in Roman numerals.